ATX, Tori Smith will present the opportunity. Tori, feel free to share your screen and do your presentation. Our Thomas, by the way, I told the story, but Thomas, sorry about that.
Hello, yes. Hello, I am Thomas. I am head of manufacturing, and I'll be presenting in the annex with Quentin, our chief engineer.
Hi.
So around the world, every 39 seconds, someone dies of stomach cancer. And an early diagnosis could impact several hundreds of thousands of patient outcomes a year. The most commonly used diagnosis process today are EGDs. And some of you may have experienced this, but these are highly invasive, expensive. They can take up to months to get an appointment. They have long lead times. Sometimes you have to take medication, and they're generally not very accessible. Within the annex, we present PillBot. So PillBot, there are no hospitals, no drugs, and no wait times. The patient can be in the clinic or in the comfort of their home. Will only have to skip one meal and swallow a large cup of water. And then the doctor could be in the same room as the patient or on the other side of the world, will be able to remote control the pill inside the patient's stomach, allowing them to perform their diagnosis.
So our journey started 5 years ago in 2019. We just turned 5 years like a couple days ago, so that's a huge moment for us. We came from a football-sized robot that looked like a torpedo, and now we are scaling down to a robot that is like really, really small, 30 millimeter of length. This journey was amazing. It included a lot of founding effort, thanks to Tori and Chris, our chief business officer, and we have a lot of patents across the world. This journey is amazing. Yeah. So this is our competition. As you can see, PillBot require no visit to the hospital, no sedation. Is telemedicine enabled. You can do this all over the world, and it's remotely maneuverable. And none of the product in the market check all this mark right now. So right now for let's talk about financial. Yeah. Right now, if a physician would like to do an endoscopy, he's going to get $118 in reimbursement. It's going to be $336 for PillBot. So a huge win for them. This is what we would like to give them, the opportunity to grow with an easy product. And like the addressable market is 10 to 100 times more with telemedicine compared to any other device that are remotely maneuverable or at hospital. This is our team. Yeah. This is our plan for the 2026 market entrance. We are doing right now, or we are starting in a couple of weeks, or OUS study in New Zealand. We are eager to start presenting the first trial as safety and reliability inside the stomach. That's a huge win for us. We are currently start to raise Series A, and we are finalizing our seed round. And yeah, PillBot is going to be the first MVP product that we're going to ship after the FDA clearance in 2026, hopefully. And yeah. So this is our team. We have Tori Smith, the CEO and co-founder, Alex Lupke, the chairman and CTO, and Vivek Kumbari, the head of Mayo Clinic for the GI department, who is one of the co-founder and board member. We are also supervised and helped by the best doctor in the world. If you see the best GI doctor, the 10 best GI doctor, this is the six of the 10 best doctor in the world in terms of GI. So we are really grateful to have them in our board of advisor.
So the plan for the future, we're currently working on Pillbot 1. Soon we'll be developing Pillbot 2, a smaller, more efficient, longer battery life version of the Pillbot. After that, we're going to transition from a passive viewer in the human stomach to an active surgeon with pill surgery. The pillbots are also essentially a data collector in the human stomach, and so we'll have a data service accompanied by AI tools and various data structures. And ultimately, we'll be going smaller, and I mean way smaller, with MEMS-like robotics inside the human brain, tackling brain tumors.
So right now, our goal is to have a remote device that the physician can control inside the human stomach, and they can detect any disease. But the final goal is to have an AI doing this for them and generating a report, so they can look at the report, check if there is any error or not, and do their job, what they're trained for, not controlling an EGD or detecting stuff inside your stomach. Everything is going to be automated thanks to AI for remote control and visual detection.
All right, I have to stop you there, and I'm sure you will talk more about it during the Q&A part. Okay, Nikki, let's start with you if you want. Start.
Yes, of course. Thank you so much for the overview. So I have a line of questioning that I think one will go into the other. So the first question, and maybe it's a stupid question, is where does the pill go after it's done doing what it's supposed to do, and how long does that take?
The pill just goes through your system, and it can take up to 72 hours, but usually just maybe 12 hours. It's out of your system. Yeah.
Okay, and then, I mean, I'm guessing it's not degradable, like it will just be discarded as such.
It will be discarded, yeah. If
Okay.
we look at just the environmental impact, it produces 500 grams of waste for a typical EGD versus 3 grams of waste for the Pillbot.
So, okay, and in terms of cost, because that's the other thing, I guess usually there are components that are reusable, but in this case that wouldn't be the case, right?
These are very cheap. They're currently $50 to produce one Pillbot, and when we go to scale, this will reduce quite a bit. And they're one-time use.
Okay. Mm-hmm. Yeah. Okay.
Great, thank you, Nikki. Cindy, do you have any question?
Yeah, so I think it's kind of a follow-up question in the sense that I want to understand that how the patient journey will be looking like a patient with a doctor, and how do they communicate, take it in, and then how is the safety, concerns that being relayed to the patient, for example.
So the communication, so there's kind of two paths, right? The patient can be in the same room as the doctor, and they can be talking face to face. But you can also imagine this being over a Zoom call. So the patient can be at home, and all they need is the Pillbot and a computer, and they can have the Zoom call with the doctor while they perform an endoscopy.
Thank you.
Thank you, Cindy. Kate?
Thanks for your presentation. So I have a couple of questions. Maybe you can just give short answers. So the first one is, are there any patient willingness issues with this vis-a-vis endoscopy?
No, there aren't really. An endoscopy is an extremely invasive process. With the pill, it's as simply as swallowing a larger vitamin-sized pill kind of thing.
Okay.
And so most patients would, yeah.
Yeah, and then you have a competitor, PillCam, and it looks like your differentiation is maneuverability. So maybe you can explain the value of that.
So it's more than just maneuverability. The cost is much lower, right? It's just a pill and a computer in the doctor's office. It also enables telemedicine. With NaviCam, the cost is a lot higher. It requires a very large structure inside the clinic, right? A huge, very large device. It's very expensive, and it doesn't allow telemedicine.
Okay, and then the last one on PillCam, they have an SBI. It's a suspected blood indicator. Will you guys have that feature?
We'll be adding them up.
Features the areas that it identifies as having blood. So I don't know that it's that sophisticated, but have you built that in?
With the first pillbot, we're really focusing on being eyes inside the patient's stomach for the doctor. With pillbot 2, we'll be adding sensors on board and various other components.
Oh, you know, one other one there. I think they talk about issues in other areas, right outside the stomach. Are you considering that also? So the intestine, for instance.
Yeah, so PillCam, for example, is a passive pill that you swallow. The issue with PillCam is that when you're in the stomach, it's a large volume, so it can't really look around. So they have to wait for it to go through, and then it looks at the digestive system. We're really focusing on the stomach, that larger volume, right? So the patient can drink water, and then the pill can track around from now. But with future iterations, we can definitely imagine, extending the battery life and taking imagery inside the digestive system as it goes through.
Okay, thank you.
Thank you. Nadine?
Yeah, one of the things I wanted to ask was that you mentioned that this could also happen. Well, at least the deck mentioned that this could also happen with ER doctors, nurses, as well as GPs in primary care could use this. But are they trained, and do you think they'd be able to interpret the results, and would they require training?
We'll definitely be starting with gastroenterologists as doctors who will be driving this. When we start adding AI tools with automatic diagnosis processes, then maybe it can open up to various other medical staff.
Okay, got it. Thank you.
Great. Thank you so much. Time is also almost up. Thank you for the presentation. Thank you for the question and contribution.
Thank you for your time.
And feel free to reach MDI Techs to learn more about the opportunity.